Hi, good afternoon. So today, as you can see, today we shall start refraction of light. Basically, this is refraction of light on plane surface. Okay, so now let's talk about refraction. Can you tell me in which class you have read this refraction? In class 8. Okay, so what is refraction? So refraction is basically, let's consider two optical medium. Optical medium means some medium through which light can pass. So let's say this is a optical medium. I am taking it is medium 1. So instead of medium 1 I can write this is as air. Okay, and I am writing this is as water. Okay, so this is air medium and this is water medium. Let's say a ray, and I am drawing, this is a normal, this is the normal process, means the process we just follow in case of reflection. This is the same process. And let's say this is the incident ray, and when a ray of light incident on the surface which is separating two different medium, in this case air and water, it always changes direction from the separation of the surface. You can see that it is changing its direction. How? If the medium is not here, then the light will go along this path, but it is changing the direction. Okay, so this phenomena is known as the refraction. Now lot of question will come in your mind, why this is changing the path, why it is not going along this direction, etc, etc. I shall give answer all of them, okay, one by one. Just listen. First let us talk about optical density. Okay, so I am writing the term here, that is optical density. Optical density. So what is optical density? Can you tell me what is density? Density, so basically we know what is density. I am not going to define again. Okay, so if we consider air and water, which one is more denser? Air? No, water is more denser. If we consider water or glass, which one is more denser? Glass is more denser. Now in case of optical density, that's mean that not that type of physical density, but optical density means which is more denser to a light. Okay, let me give an example. If you consider two cases, turpentine oil and water, okay, and some glycerin and glass means we know kach. So okay, we'll leave the turpentine oil, some water, glycerin and glass. Okay, so among all of them, water is rarer, means not denser, less denser. Then we can say the glycerin and then glass, that means glass has the highest density. But in case of optical density, water is rarer, okay, glass is denser, okay, then what about glycerin? In the previous case, that means in case of normal density, glycerin was intermediating, that's mean water has lowest density, normal density, glycerin has moderate, and glass has highest density among all of them, among all these three. Now in case of optical density, of course water is not denser, glass is densest medium among these three. But what about glycerin? Actually the density, that's mean the optical density of glycerin and glass are same. The optical density of glycerin and glass are same. Okay, now don't ask me why. Actually this is the property of the medium. This is property of the medium. That's mean in which medium light will act like how the light will act, that's completely depends upon the medium. Okay, so that is why the optical density of glass and glycerin are same, and water is less denser means rarer, and air is more less denser, that's mean more rarer than water. Okay, so this is rarer medium, this is denser medium. Similarly we can write here water or glass. That's mean instead of air or water, if we take water and glass, then the picture will be like this. The same figure we can get from here. Okay, now you may ask question, if the light can go from water to air, then what will happen? It will go along this direction. Now look at this picture very carefully. If the medium is not here, then the light can go along this path. Look at this line. This line is known as the normal or perpendicular. So when light is going from rarer, so this is rarer and this is denser. When light is coming from rarer to denser medium, mind it, rarer to denser, the refracted ray, that means this is the refracted ray always come close to the normal. And when the light ray pass from denser to rarer medium, the light ray always go away from the normal. Is it clear? বাংলায় বলছি, দেখ যখন রেয়ারার মিডিয়াম থেকে ডেন্সার মিডিয়ামে আসে তখন এই নর্মালটার কাছে সরে আসে, আর উল্টোটা যখন দেখ ডেন্সার থেকে রেয়ারার মিডিয়ামে যায় তখন এই নর্মাল থেকে দূরে সরে যায়। দিস ইজ দ্য অনলি রুল। Okay, and this rule is applicable for all of these cases. This case also, water is rarer, glass is denser, so it is coming close to the normal, and this case is like this, that means is going far from the normal. Okay, is it okay? So this is the normal phenomena. Now again you may ask me, sir, why this is coming to this and why this is going far from this? Actually, just think about it. Suppose you are running and suddenly your friend just pulled your hand, so what will happen? You will change your path. Okay, this phenomena is something like that. The light was just going, okay, but suddenly this medium is resisting its speed. Okay, that is why it is bending like this. Let me tell you, we know the speed of light, that is c equal to 3 into 10 to the power 8 meter per second, and we know this is constant, but this is the speed of light in vacuum or in air. They are nearly equal, but the speed of light in glass or water are different. I shall show you the speed of light in glass, that is 2 into 10 to the power 8 meter per second. So just look at this. The speed of light in glass is different. Actually, I shall tell you how to calculate this. This is a numerical problem, whatever. So this is the phenomena actually happening here. That's mean the speed of light is different for different type of medium. Is it okay? Okay, so I'm going for another video because its size will increase. Okay, so in next video we shall discuss about Snell's law or the laws of refraction.